Hello out there in TV land! This video is going to teach you about the elimination method for solving a system of linear equations. Are you ready? Let's go! Okay, so I'm here with Isabel, and we're going to talk about elimination. Isabel, if I asked you what does the word eliminate mean, what would you say?
To take away or get rid of.
Exactly. You're going to get rid of or eliminate one of the variables, and then you just have to solve for the one that's left over. The key is knowing when to use this. Let's take a look at this problem here. When you look at the coefficients on the x, these numbers are opposite of each other. If you have either opposite numbers, which you have here, -6 and a +6, or you have exactly the same number, the idea is that you're going to add or subtract these equations in order to eliminate one of the variables.
So how am I supposed to know if I'm supposed to add or subtract?
That's a great question, Isabel. In fact, there are two rules that you need to remember. The first rule, if the signs are the same, you want to subtract the equations. The second rule, if the signs are different, then you want to add the equations. Okay?
Okay.
So a big part with elimination problems is understanding which ones you should actually use this method for. So here I'm looking at the coefficients in front of x. Right now they're both 6. If you see that, then that's a perfect candidate for elimination. Here, they're 5 and 4, so that would say no. If these were different, then it would say no, but they're the same. Okay? Now, when I was talking about the signs, here one is negative and one is positive. So if the signs are different, you're supposed to
add.
Correct. I need to add them. Now what I want to do is, let me pretend this wasn't here. Okay? And I'm going to show you why this works. And I say, all right, I have a -6x, and I'm going to add a +6x. What does that become?
0.
Yeah, 0. It was eliminated. That's the idea. So let me rewrite the rest of this in. And what was it again? Plus 4y equals -10. Look at you. My memory is not so good and yours is great. So now the difference is we got rid of this. Now what we need to do is add these terms and then add these terms. So 5y, a +5y and a +4y is
9y.
9y. I'm going to get rid of this because we really don't need to write 0. And then I have a +1 plus a -10. -9. Divide by 9. Notice how the x's are gone, and y is equal to -1. Now that I have one of mine, I could solve for the other one. So now what I'm going to do is substitute this in for y in either one of the equations, so it doesn't really matter. I have -6x and plus 5 times y, which I'm saying is -1, is equal to 1. -6x is going to be -5 is equal to 1. Add 5 to both sides because I'm solving for x. -6x, you saw what happened there, is 6. Divide by -6 on both sides, and x is equal to -1. Wow, that's a cool coincidence. So my solution is -1, -1. And again, I would want to check that to make sure that it actually worked in both equations. Because if it worked for one, that just means it's on that line. In order for it to work for both, that's where the lines cross.
That's pretty easy.
All right, well, let's try one that you might not consider to be easy.
Uh-oh.
Take this problem, for example.
Oopsie.
All right, that was random. Let's get back to the problem.
Hold on. The coefficients are not the same or the opposite. So isn't that a substitution problem?
That's a great question, Isabel, because this actually would be something I would solve by substitution, but let's assume that your teacher wants you to solve this by the elimination method. The question is, how would you do it? Okay, so in order to do elimination on a problem like this, what we need to do is change either this -3 to a +9, or change this 1 to a -4. Which one would you like to change?
Let's change the y.
All right, what do I have to multiply a negative 3 by in order to make it a positive 9?
Negative 3.
Negative 3, correct. So this is what I'm going to have to do. I'm going to take this equation and I'm going to rewrite it like this. And then I'm going to multiply by a negative 3. Now I have to do that to every term, which means this is going to get distributed to the terms on the inside.
Hold on a second. Why do I have to multiply every term?
That's a great question, Isabel. Let me erase this problem for a second and give you an example that might make more sense to you, okay? I'm going to give you a simple equation. X plus 5 is equal to 15. For this equation, what is x equal to?
10.
Right. So I'm going to write it up here just so we remember. X is 10. Now, if I multiplied one term by some number, let's say 2, I'll do 2 times x. Is x still 10?
No.
What is it?
It's 5.
Right, because you subtract 5, divide by 2. So what I have to actually do is multiply every term by 2, and you'll see that x will still be 10. So I do 2 times x, 2 times 5. I have 2x plus 10 is equal to 2 times 15, which is 30.
Okay.
Subtract 10 from both sides, 2x is 20. Divide by 2, x is still 10. Because I multiplied every single term by the same thing, it kept it so it's still balanced, okay? It's still, doesn't change the variable.
Okay.
Make sense?
Yep.
Cool. So what we're going to do is we're going to multiply each term by a negative 3, because again, we want to change this negative 3 into a positive 9. So a negative 3 times x is?
Negative 3x.
Yes. A negative 3 times a negative 3y?
Is a positive 9.
Positive 9y, correct. And then a negative 3 times a negative 6?
18.
Correct. Now what I'm going to do is I'm going to erase this up here and bring this equation over so we can combine them. The reason I'm doing that is I don't want to get rid of the one that was originally given to me.
Okay.
It doesn't really matter though. So a negative 4x plus 9y is equal to 9. And what I'm going to do, I want to know, do I add or do I subtract these, Isabel?
Subtract.
I'm going to subtract them because the signs are the same. And 9 minus 9 is 0. Where you got to be careful is right here. This double negative, that really throws some kids off. You want to remember there's negative 4 minus a negative 3, which is the same as a negative 4 plus 3, which would give me?
Negative 1.
X. Right. These terms are gone, right? And then I have a 9 minus 18.
Negative 9.
Correct. And then I don't want this, because that means the opposite of x. I want to know what x actually is, so what do?
You would divide by negative 1.
You got it! Negative 1, and then x is a positive 9. Okay? Are we done?
Yeah, no.
No, we're not done, because we need to solve for?
Why?
Why? Oh, you're really sharp today, aren't you? Great. So what I'm going to do is I'm going to take 9 and I'm going to substitute it in for x. Okay? And it doesn't matter which equation I use, but I'm going to do this one because it looks really easy. I don't have to do any multiplying. And I'm all about easy. So I'm going to do 9 minus 3y is equal to negative 6. Okay? I want to get rid of the 9 first. So I'm going to subtract 9 from both sides. They're gone here, leaving a negative 3y. And then, what is a negative 6 and a negative 9?
Positive 15.
Yeah! No.
No.
Think about that for a second.
Oh my god.
A negative, you're thinking multiplication.
Oh,
Negative
gosh.
6 and negative 9 is going to be negative 15. Right? Signs are the same. Add them, keep the sign. That's okay. It's pressure. It's Hollywood. You know how it is. All right. Now, how do I get rid of the negative 3?
You divide by negative 3.
Correct. Negative 3 on both sides. Whoops. And y is equal to 5. So my solution then is 9, 5. All right? And again, you want to check in both equations to make sure, because here, if it's answered, if you put it into here and it gives you a true statement, that means that it's on that particular line. But you have to actually check both because you want to make sure it's on both lines or where the two lines happen to cross. Okay. Now, you probably think we're done, but there is an interesting case that you need to be aware of. Actually, I can say 2 interesting cases. Are you ready? So here's our special case. when you look at this one, if you want to solve it by the elimination method, what makes this problem tricky?
Well, you can't multiply 2 by a number to get -5, and you can't multiply 8 by a number to get -20. So what do?
You're a genius. You got that right away. What you want to do is you want to look at either the numbers that are in front of your x or the numbers in front of your y, and you want to figure out what is the least common multiple of those two numbers. Now, it doesn't need to be the least, but that just makes things a little bit easier. So when I look at 8 and 20, that's going to be a large number. 2 and 5, it's really small. What would be the least common multiple of 2 and 5?
10.
Right. So what we want to do is multiply this equation by 5, and turning this into a 10, and multiply this equation by 2, turning that into a 10. Make sense?
Yep.
Let's do it.
Okay.
So when I multiply this, it doesn't matter if I multiply this by a +5 or -5 and this. It doesn't really matter, because remember, we can add or subtract them. The point is that they're both going to have 10 out in front. Okay? So what I'm going to do is I'm going to take this equation, I'm going to rewrite it over here. -5x plus 20, oh, that was minus. Should have caught that. Minus 20y is equal to -15. And then I'm going to erase it from over here. Okay. So what I'm going to do, that looks ugly, I'm going to take this equation here, and I'm going to multiply by a +5. And do that on both sides. Aha! Okay. There. 5 times 2 is 10x. 5 times a +8, I get plus 40y. And then over here, that becomes 30, right? Okay. Over on this one, I'm going to multiply by 2, because again, I want them both to have 10. And it doesn't matter if it's positive or negative, because when you subtract them, it doesn't matter, or add them. You could either one, depending on what you get. I just want the number to be the same, okay? So I have this times this times this. 2 times a -5 gives me a -10x. 2 times a -20 gives me a -40y. And then over here, this is a -30.
Wait. These are the total opposites of each other.
Brilliant! That's exactly what I wanted you to get. That's the special case. Okay, so what I'm going to do is take this equation, -10x minus 40y is equal to -30. And I'm going to bring this equation underneath it, 10x plus 40y is equal to a +30. And what I'm going to do is I'm going to add these because the signs are different. What happens to these?
0.
They're 0. What happens to these?
0.
What? And then what happens here?
0.
What? So the special case is that the variables, both the x and y, disappeared. If that happens, you have one of two possible solutions. The first one, if they both disappear and you end up with a true statement, that means that they're the exact same line. They're on top of each other and you have an infinite amount of solutions. If you end up with a false statement, both x and y disappear, then you end up with your second one, which means that the lines are parallel to each other, they'll never touch, and there's no solution.
I get it now.
Awesome!
Mind blown.